Hi, let's continue. Important questions on functions part 4. Question number 16. If g inverse 2x minus 1 is equal to 3x plus 2, find gx plus h minus gx over h. So, solution. We are given g inverse 2x minus 1 equal to 3x plus 2. So from this g inverse 2x minus 1, we'll try to find out g inverse x. Is this clear? First of all, we'll try to find out g inverse x. After finding g inverse x, we are going to get gx. So let's continue. This portion, which is inside a bracket, we'll suppose this as a. So let 2x minus 1 equal to a. We will solve this for x, or 2x is equal to a plus 1. Therefore, x is equal to a plus 1 by 2. Now, this value of x we are keeping over here and over here. Instead of 2x minus 1, directly we can put a. Or if you want, you can put a value of x, that is a plus 1 by 2 over here as well. Both the ways are correct. Now, therefore, g inverse 2x minus 1 equal to 3x plus 2 can be written as, or g inverse, instead of 2x minus 1 we can put a. So instead of 2x minus 1 we are putting a equal to, now this 3 same to same, here is x, this x can be replaced by a plus 1 by 2, so it is a plus 1 over 2, and this plus 2 as it is. After this, or g inverse a is equal to, let's simplify the right hand side. We are getting 3a plus 3 over 2 plus 2. Let's take LCM. It is 3a plus 3 plus 4 over 2. It is equal to 3a plus 7 over 2. So therefore g inverse a is equal to 3a plus 7 over 2. Now we can replace this a by x. But as soon as you replace this a by x, this a must be also replaced by x. So therefore g inverse x is equal to 3x plus 7 over 2. We have found g inverse x. Now, with the help of g inverse x, we are going to find out gx. So, let y is equal to g inverse x, or y is equal to g inverse x means 3x plus 7 by 2. So, 3x plus 7 by 2. Interchanging the rule of x and y, we get x is equal to 3y plus 7 over 2. Now we will solve it for the value of y. So, or it is 2x minus 7 over 3 equal to y. Therefore, y is equal to 2x minus 7 over 3. This y is obtained after interchanging the rule of x and y. So this y will represent now gx. So therefore gx is equal to 2x minus 7 over 3. So we have found gx. Actually the question has given to find, sorry, the question is asked to find gx plus h minus gx over h. We have found gx. Now we need to find gx plus h. So let's find out gx plus h. Just a moment, let me create some space. Okay, so therefore gx plus h is equal to, instead of x we are going to put x plus h. So in right hand side as well x plus h. So 2 in bracket, instead of x we are going to put x plus h minus 7 over 3, or g in bracket x plus h is equal to 2x plus 2h minus 7 over 3, isn't it? Okay, we have found g in bracket x plus h, but question is asked to find out the value of gx plus h minus gx over h. So let's continue then. So gx plus h is 2x plus 2h minus 7 over 3 minus gx. Gx is 2x minus 7 over 3 whole upon h. Okay, just let me put equal to in between. Now equal to, the numerator part has to be solved by taking LCM. So the LCM is 3. So we get 2x plus 2h minus 7 minus 2x plus 7 over 3. Isn't this? Okay, this plus 2x and this minus 2x cancelled. This minus 7 and this plus 7 cancelled. So ultimately we are left with 2h. So it is equal to 2h by 3 over h. This equal to must be over here. Now again let me create some space. Okay, now we can write this as 2h by 3 into 1 by h. This h and this has cancelled. So ultimately we are left with 2 over 3. So this is our answer. Now let's go to next question. Question number 17. If f of x plus 2 is equal to 3x plus 2 and f inverse x is equal to f inverse 2, find x. So, solution, we are provided f of x plus 2 equal to 3x plus 2. We are given f inverse x equal to f inverse 2. So first of all, we need to calculate f inverse x. To calculate f inverse x, we need fx. But fx is not provided. So we are going to calculate fx with the help of f of x plus 2. So let x plus 2, this one is supposed as a. Therefore, x is equal to a minus 2. So from our given condition, therefore f of x plus 2 equal to 3x plus 2 can be written as f of, in place of x plus 2, we can put a is kept equal to 3, here is x means a minus 2, so we can put a minus 2 in place of x and this plus 2 as it is, or it is f of a equal to 3a minus 6 plus 2, it is equal to 3a minus 4. So we have found, therefore f of a is equal to 3a minus 4. Since we have found f of a, now we can write, therefore f of x is equal to 3x minus 4. Just we have replaced this a and this a by x. Okay, we have found f of x. Now we are going to find out f inverse x. So let y is equal to f of x, or y is equal to 3x minus 4. Then what do? We interchange the role of x and y. Please mention it yourself. So on interchanging, we get x is equal to 3y minus 4. We solve it to get the value of y. So we get y, therefore y as x plus 4 over 3. This y is obtained after interchanging the role of x and y. So it will represent f inverse x, which is equal to which is equal to x plus 4 over 3. Now question has given f inverse x equal to f inverse 2. We have to use this one to find the value of x. So let's continue. So by equation, f inverse x is equal to f inverse 2, or f inverse x is x plus 4 over 3. Now f inverse 2 means this value 2 has to be kept in place of x, isn't that? So if we keep 2 over here, we are getting 2 plus 4 over 3, or let's simplify it. So it is x plus 4 over 3 equal to 6 over 3. This 3 and this 3 can be cancelled, or we have x plus 4 equal to 6, or x is equal to 6 minus 4. Therefore, x is equal to 2. So this is our answer. Question number 18. Find the image of 2 and pre-image of 6 from the following mapping diagram. So this diagram is provided. From this mapping diagram, we need to find the image of 2. So from this diagram, can you say what is the image of 2? 2 is related to 4. So the image of 2 is 4. Similarly, can you say what is the image of 4? The image of 4 is 8 because 4 is related to 8. Is this clear? Similarly, question is asked to find out pre-image of 6. 6 is over here and 6 is related to 3. So we say the pre-image of 6 is 3. Similarly, what is the pre-image of 10? The pre-image of 10 is 5. Remember, 10 is image of 5, but 5 is pre-image of 10. Similarly, the image of 3 is 6, but the pre-image of 6 is 3. So is this clear? So we can write we can write image of 2 is 4 and pre-image of 6 equal to 3. Is this clear? Okay, now let's go to next question. Question number 19. So the question is, write the condition for the function to have its inverse. So we need to mention the condition for any function to have its inverse. So first of all, let's understand through a mapping diagram. Suppose this is a function f. Let's say here are elements a, b, c, and here are elements d, e, f. Let's say a is related to d, b is related to f, and c is related to e. So we can say the image of a is d, the image of b is f, the image of c is e. Or we can say the pre-image of d is a, the pre-image of e is c, the pre-image of f is b. Means every element in the second set has got one and only one pre-image. Isn't this? D has got only one pre-image, that is A. F has got only one pre-image, that is B. Similarly, let's take one more example. Suppose this is function g, and here we have suppose m and o. Here we have suppose 1 and 2. Suppose m is related to 1, o is also related to 1, and n is related to 2. So in this case, we can see the pre-image of 1. The pre-image of 1 are 2 in number, that is m and o. 2 has got only one pre-image, that is n, but 1 has got two pre-images, m and o. So we can say over here 1 has got two pre-images, but in this diagram no elements of the second set has got more than one pre-image. Is this clear? Now let's try to find the inverse of this function. So the inverse of this function is obtained by interchanging domain and range, isn't this? So we can write the elements of this set D, E, F over here, and the elements of this set A, B, C over here. Okay, now D is related to A. E is related to C, F is related to B. So we have found F inverse, isn't this? Now let's try to find the inverse of this. Let's see if it's possible or not. Now we interchange domain and range. Okay, so we write here 1, 2. Here we write M, N, O. Now 1 is related to M as well as O, and 2 is related to N, isn't this? But is this relation a function? Just think, is this relation a function? No, this relation is not a function, because according to the definition of function, every element of the first set must have a unique relation with the elements of second set. Means the element of first set must not have relation with more than one element, isn't that? But this element 1 has got relation with M as well as O, isn't this? So this is not a function. So we are able to find the inverse of F, but we are not able to find the inverse of G, isn't this? Now can you guess why? Can you guess why? The reason is, in function F, every element of the range set has got one and only one pre-image. D has got only one pre-image. E has got only one pre-image. F has got only one pre-image. But in function G, the element 1 has got two pre-image. Isn't this? That's why the inverse of G cannot be obtained. Is this clear? Now, this function is known as 1 to 1 function, or simply 1 1 function, and this function is known as many to 1 function, or simply many 1 function. So many 1 function or many to 1 function does not have inverse, but 1 to 1 function or 1 1 function has inverse. So this is one condition. So the first condition that we have learned from here is the function must be 1 1. Is this clear? Now there is one more condition, that is the function must be onto function. So what is meaning of onto? Onto function means range set must be equal to codomain set. Means what? For example, let me explain it through an example. Suppose we have again two sets which are related by a function f. Suppose here we have A, B, C. Here we have 1, 2, 3, 4. Now here, suppose A has gone to 1, B has gone to 2, C has gone to 3. So in this function, what is range? Range is equal to 1, 2, 3. And what is codomain? Codomain is equal to 1, 2, 3, 4. So is range equal to codomain? In this case, is range equal to codomain? Just think and say, no, range is not equal to codomain. That's why this function will not have its inverse. Let's try. So suppose it has inverse. So we interchange domain and range. So here we write range 1, 2, 3, 4. Here we write A, B, C. So 1 is related to A, 2 is related to B, 3 is related to C. but 4 is not related to any element. So is this a function? Is this relation a function? No. Since it is not a function, its inverse is not possible. Is this clear? So only in a function where range is equal to codomain, it will have its inverse. Is this clear? So finally there are two conditions. The first condition for the function to have its inverse is it must be one function. Second condition is it must be onto function. Is this clear? Okay.